Right, I'm just going to do the first part of the external calibration on this. It's quite straightforward. One of my viewers was asking about the external calibration, and there's one particular test that I'm not going to actually do tonight, because I haven't actually got gear that will actually produce a square wave fast enough to actually do the calibration. But the next test I'll do is this external diagnostics. No, I won't. I'm sorry. I'll do the external calibration. So press this button, and we're going to go to attenuators, and we're going to go to attenuator gain, as you can see there. Hopefully you see there. Let's bring it in a bit. It says connect channel 1 to a 0.2 millivolt source, which we're going to do. .2 millivolts is set by the Philips signal generator on its DC mode. Let's get it as close as possible and press a button. 2 volts. As close as possible. I need 20 volt supply. Now we do that from the one of the row-bound power supplies. The easiest way of doing this, probably, just click it straight up. I know I'm out of frame and I can't keep moving the camera about. It'd be a pain. So I'm thinking 20 volt supply. Smack on. Press the button again. Now I'm going to channel 2. Same procedure. But I want 0.2 volts first. Volts. And 20 volts again. Pass. Attenuators passed. Just calibrate the attenuators, so that's good. So everything's looking hunky-dory. Now let's just see what else we've got to do. We've got the channel delay. I'm not sure I can do that. What does that need? Running. Repeat cal first. Okay. So going back. Oh, here we go. What's this? This is connect both channels to. Oh no, this is no. I bought that. It's bought that because it's told me to do the repeat cal first. Okay, so cal diagnostics. External cal's uncalibrated because I haven't tested the all the parts of the attenuator. So the attenuator should have passed the gain attenuation, but still passed the channel delay. We know about that, so we'll go back. I think we can go back. We go trigger, which is uncalibrated. Connect trigs to ground, and then we'll press. Okay, so we're sure the trig level points out, so we'll do that quickly. Probably the easiest thing to do is connect up a 50 ohm terminator to the trigs. Bear in mind I've got one of the trigs is damaged, so I'm not sure if the BNC will actually fit it. Let's try. This is actually a damaged connector I should really replace. I think it's not going to go on there. So what I'll do is I'm going to straighten that out quickly. Got a damaged BNC down here. Where it's been dropped or something. see if I can get this just to short this out. It's the neck of this BNC. So I'll short it out and I'll just replace that connector at a later stage. I'm not too worried about that at the moment. I just want to see if I can get this to cal properly. So short these two out. Let's try it, see what we get. And press menu off to abort, press A key to do it. Okay, I need to supply voltages to these leads, so what I think I might do is abort this trigger option at the moment, because I think I need to replace that connector or certainly repair it. But it's clearly going through all the calibrations, no problem at all. This is the tricky one here, this CTE scan, CTE cal, and that's just this one here. This one requires a really fast rise time. Should be able to pass this one now actually. So, let's abort this. Let's see if I can run the one for the. Where are we? It's Cal Diagnostics. Okay. External calibration, attenuator, and then channel delay. Connect both channels to a fast rise signal. Okay, so I can't do that at the moment. So we'll leave this for the minute. I'm going to try and replace that connector and then we can perform the rest of the calibration. Right, following on from last night with the scope, and we seem to have got a bit further. Left it last night with needing to calibrate the external triggers, but there was a damaged BNC connector on the board that I've replaced in this scope. So what I've done is I've unsoldered the BNC adapter and replaced it. This is just unsolders this part, just comes disconnected. You've got the trigger A and B here, or trigger 1 and 2, and the external point for the calibrator. So that's been replaced with the one off the board from the original unit. At the moment we did a sort of partial calibration and it all looked like it was working okay. So what I want to do this evening, hopefully, is to calibrate the other parts of the scopes. I'm not going to do any adjustments on the board itself. I'm going to see if we can pass calibration without that, because it's a real laborious job. Done that before on the other scope. Didn't notice any improvements on performance of the scope, so if we can pass it, we're just doing the software calibration. That's what I'm going to do. Pop the scope up on a box so we can actually work on it a bit easier and you're not working on the side. I've still got the fan underneath the unit blowing on the CCDs and the peak detectors. They're the things that run the hottest. You can't run these scopes, I've said this 100 times, I know. You can't run these digital scopes without calling on their hybrids. They will fail, and if they fail, you're going to spend months looking for parts for them. So let's power it up. We'll see how we get on with the calibration process. Unfortunately, it does need a 15-minute or so time to warm up. So what I might have to do is have to pause the video. And I'm just trying to see if I can get the light a bit better. Let me just turn the workshop light so I can see a bit better on the CRT. I'm going to zoom in a bit to the scope itself, so hopefully you can see what's going on. And then we're just going to have a quick look to see what we've got. So now you see that as we had previously, before we changed the CCD in the boards, we are now passing the CCD test, which was the big problem. We've got a PA fail. I also had a problem last night with this last membrane switch wasn't working properly. That seems to have been resolved by cleaning the contacts on the connector and also trying to spray some contact cleaner into these switches. Hopefully that will work properly now. So I'm going to scroll down and I'm going to just have a look at our PA status and see what it says. Okay, so we've basically I did the attenuators last night, they passed. The only thing that's failing now is the attenuator channel delay. Okay, so that's good. You'll also notice that now it no longer says hardware fault or hardware problem, consult Tektronix or whatever it said before. So it clearly thinks it's working fine, so that's good. So we'll quit from that for a minute. We'll just check the trigs. I think trigs is basically because it hasn't been, and the gains haven't been set. It's past everything else. So this is all looking excellent. It's all looking what I'd expect from a scope that just needs calibrating. So it's a sign here saying not warmed up at the moment. I'll probably have to go and allow this to run for a while just to let it to settle down. But in the meantime, I'll just show you something else that I just need to reiterate what you'd expect to see on a scope with 40 CCDs, and I'll show you this now. If we go to acquire mode, we're acquiring at 200 microseconds, got both the channels up, and you can see that the waveform's nice. You've got no problem at all with shifting the levels up and down, as you see. Now that's running in real-time mode at the moment, but when it starts to go into its, I don't know, I can't remember what the work term they use for it, but it's the time where, because you're sampling, you're looking for frequencies of such high frequency, what it does is it grabs the data from the front end of the, or the source you're looking at, it puts them into the CCD, this is the sort of layman's terms, and then it builds up a picture of what the waveform looks like. And that happens, I think, over about 10 microseconds. Now you'll see in a moment, 10 nanoseconds. We're now in that mode. We're now using the CCDs for checking. And if your CCDs are faulty, if I wind this position up here, if you remember from the previous video, you get a load of scattered lines. We're not getting that anymore. We're getting the classic CCD, slight disturbance in the waveform. It's exactly the same as what the other one does. And you can see I'm at 5 volts per division. It makes no difference what range I am. That is just background noise from the CCDs. I've also found that improves when the scope warms up. So I'm not worried about that. That's the normal thing. It's got the repeat mode on here, and you'll see if I press this is how it builds the waveform up, and you'll see if I press this, you see what it's doing. It gathers all the samples together. To me, it looks like it gathers all all the data, builds the data up, and builds a picture. If you change the time base, it's doing it again because it's taking that very fast information from the front end of the scope, feeding into the CCDs. The CCDs basically paint the picture, like a bit like numbered. Draw a dotted, the dots that you used to do as a child. You just follow a pen across and join all the lines up. And then that data can be manipulated and put into the memory, because then the computer, the processor and the scope can handle it. That's my understanding of how it works anyway. So basically this scope is not in real time anymore. When you come back out of real time, it's in real time now, you can see that the repeat mode doesn't make any difference. So that's a sure way of telling if you're in real time. That's in real time, gone out of real time. Anything over 50 nanoseconds is in alternate time, or whatever you want to call it, but the CCDs are being used to process the information. So we're gonna calibrate the as I say, we're going to calibrate the trigs and hopefully the last part of the attenuator. There is one other test you need to do on these, and one of my YouTube viewers asked about it. It's the I'm going to just see if I can call it up. It's this is the one thing that I couldn't calibrate in this workshop. I had to take it to work because it was so tricky to do, and it's you have to apply a very fast rise time. It's a CTE cal. Basically what it asks you to do is put a certain frequency in with a very fast square wave rise time. The Philips signal generator wasn't capable of doing it. I tried a few other things. I tried the Rodin short signal generator with its square wave output, but it just hasn't got that really sharp, fast rise edge to allow the scope to calibrate. But we will have another try this evening and see if we can get anywhere with it. But first of all, I want to finish off the attenuators, and I also want to sort out the trigger as well. So let's see if it will allow me to do anything now. Okay, connect both channels to a fast rise time signal via a terminated coax and a dual input connector. So basically what it's saying is fast rise time, I mean, it doesn't say what fast rise time signal via the terminal. Now I might need to look at the manual for that, but let's just see what we get. So put some leads together. It says terminated, obviously it needs to be terminated because of the keeping the waveforms nice and sort of uniform. Let's see what we can do with this. Couple them together. Now ideally you're supposed to use two identical leads. At the moment I'm not going to do that. Now what does it... I think I'm going to have to probably check the manual for this, but because I'm not getting anything on the display. Mind you, I'm not putting a signal in, I don't think. Square wave. Anything required? Let's just run and see what it says. Oh. Didn't specify the frequency, so I don't know if this will pass, but it's doing something. You see it's running through a calibration mode, and you see that the lines there, that's in its no, okay, it's failed the channel delay. So it probably means that I haven't got the right frequency. I probably need to read the manual for that. And also, oh no, it's past it. It hadn't finished. I was impatient. So channel delays passed. Excellent. So what have we got now? We've got trigger. It's allowing me to run these things now. So I've got everything's passed apart from trigger now. So connect triggers to ground and then press the bezel button. And you. Okay, so I'm not going to ground. I'm just going to put attenuate across them. Basically short them out. That's fine because they're a 1 meg input anyway. So a 50 ohm resistor across 1 meg is as short as a short will be, sort of thing. Running. Connect to 1/2 volt DC and then connect 1/2 volt. Connect trigger to 1/2 volt. Okay, so I need to check the DC level on the I'm not going to move the camera. You're just going to have to trust me that I'm setting it to 1/2 volt. So I'm using the Philips calibrator to produce a DC level at 1/2 volt. It's easy. It's nice and easy to adjust. It's more accurate than the my power supplies will do. It's more stable, really. Just try and get it as best as I can. Setting it now, so we're going to set to 1/2 volt as close as I possibly can. That's pretty spot on. Now you are supposed to use identically length leads, but you've got to still bear in mind that the input's such a high impedance it's not going to make any difference to a DC level. Press a button. Running. Now 2 volts. But it asks me for 20 as well. 2 volts. Passed. Okay. So let me just show you. So we got attenuator pass, triggers passed, repeat passed. Now it's the last one is the dreaded CTE cal, and I know this is one of my customers or one of my viewers wanted to see. This must be the last calibration step. Connects a 6 volt. A 6 division step, which means basically 6 volts or 6 divisions vertically to channel 1 and 2 via a 5 times pad, which basically means that 5 times pad is an attenuator, and what it's expecting you to use is a particular piece of Tektronix equipment that I'm not going to use. I'm using something else. This is really where cable lengths are quite important, because we're running at quite high frequencies. But we'll try. Got to set the frequency to 100 kilohertz and press a bezel to continue. So what I hope to do is, I might have to put the lights on the workshop. I'll put this light on for a second, just going to, so I can set the frequency. I can't see what I'm doing in here. So 100 kilohertz. So what are we doing? We're just going to check the frequency on the signal count, frequency counter. So just bear with me 1 minute. So what I'm doing now, I'm setting the frequency as close as I can get to 100 kilohertz. I don't think it's ultra critical, but that is pretty good on 100 kilohertz. Connect it back up to the. Now I'm adjusting the attenuator. Turn the light up so you can see again. Okay, we've got an offset on there. Oh yes, because I have got the offset turned on when my DC offset is off. I can straight away see, it looks to me like we're not going to get the rise time we need. But we shall try. And you can see that rise time is pretty sloppy. I don't think we're going to meet. Let's just make sure I'm on 50 ohms. Yep, so the 50 ohm termination is actually on the other end of the scope. The scope's terminators are on 50 ohms. Well, we'll try it. So we'll set it to six divisions. Turning out the graphical really, but it's 1, 2, 3, 4, 5, 6 divisions. Let's execute. Now, the last time I did this, it either hangs the machine or it just sits there forever. Executing. Input is not centered. Really? Okay. It does show a slight DC offset actually. Input is not centered. It might be I need to run a calibration again on the rest of the scope just to check it's right. So it's 1, 2, 3, 4, 5, 6. It's pretty good. Try that. No, won't have it. One, 2, 3, 4, 5, 6. Nope. So it says connect a 6 volt div step to channel 1 and channel 2 via a 5 times pad. Okay. And the dual input connectors and center both channels and set frequency to 100 kHz. No, okay, does it mean there? Does it actually mean I'm setting the ground point to the center of the CRT. Like that. Running. Okay, that's what it meant. It just says running. Now, this might take a while. It hasn't. The last time I left it at work. I just walked away with it and got on my work and came back. I think about 20 minutes later, and it had passed. To my surprise. So I'm going to pause the video, and then we'll see if it comes back with okay. Well, it finished, and with a fail, which is fine because that's sort of what I was expecting. We can't really get a fast enough square wave on this. Just trying to find a way if we can improve it at all, but I don't think we can. It's this horrible sort of, I mean, it's only a basic function generator. What I'm going to do then is I'm going to try the square wave out of the Roden Schwartz, and straight away that looks actually better than we had. I think I can adjust the amplitude because I'm actually using the square wave function out of the generator. I'm not sure I can adjust the level on that, so I actually might have to use a padder for that. That could be difficult actually, because I don't think I've got an attenuator that will bring that down. No, I haven't. I can't reduce the output, unfortunately. I can't reduce the output from the Rohde & Schwarz. Not from its square wave output anyway. I'm running out of options for this particular test. Let's plug it back into the Philips and see if we can get a better response out of it. See, this is the problem. We need to get this square wave better than it is. Actually, I just noticed when I pressed that button, everything moved about. I wonder if I can actually adjust that and the square wave level out. No. No, it's definitely not adjustable. I'm gonna... So I'm going back to the Philips again. Let's try different modes just to see if we can get a better square wave. No. The level slightly. Okay, I've increased the level. No interest. Yeah. Okay, let's try one more time. Input amplitude is too large. Too large. Running. Okay. And what we might need to do is just recheck the attenuated calibration, because you see that one level looks slightly higher than the other. Let's run this through again. I'm going to pause it again, and if it fails this test, what I'll do is I'll probably abort this test. I suppose I could borrow a function generator from work so I could video it. So we'll see what happens with this test. I'm going to pause so you're not seeing here. Okay, as you can see, it's failed again. I'm going to have a quick look, see if I can hook up a attenuator for the Rohde & Schwarz, and then we'll, if I can, I'll run that video, and if not, I'll have to borrow a generator from work. Right, I'm just running it through again. I'm using the Ballantine scope calibrator. I've just realised it's got a quite fast square wave output, and it looks actually good on the waveform, much better than the Philips was doing. I've just started it, so it might continue. It might complete with this. Really nice bit of kit, this scope calibrator. It's old, but it really performs well. American-made piece of gear. I must admit, I do like the American gear. And there you go, passed the calibration. So that concludes the calibration of this Tektronix scope. Concludes basically everything. There's no more to come. The end of a long, hard graft really with this scope. I suppose I should sort of summarise really with these Tektronix scopes of this era. If you're going to buy one, you need to be sure it works. Unless you're quite happy to sort of spend time messing about with it. I mean, it took me a long time to obviously fault find this. I was convinced it wasn't the CCDs, basically because I thought that both the CCDs won't fail together. That's wrong, they can fail together. This one clearly did. Also, be wary of the service manual when you're checking DAC voltages. Don't do what I did and get stuck in a loop for 2 months checking DAC voltages and then realise that it was nothing to do with the DAC. It was actually the manual was wrong. So be sure that you're you know that what you're doing is correct. Ask questions. Obviously, if anyone's using one of these scopes, if I can remember when you ask me, I'm more than happy to help. Keep them ventilated. if they're on a bench, make sure they've got the feet on. If they haven't got the feet on, the thing will overheat. It needs convection air underneath the cabinet, needs a space for the air to get through. You'll see if you look under the side of the cabinet, there's a ventilation hole for allowing air to move past cleanly, and if that restriction is, if that air restriction, there's air restriction there, the scope will just basically overheat and it will be dead. And that applies to a number of these models, these scopes. Keep them ventilated, and they should last really well. And the other common sense thing to do, I know all the older people will know this, and the people who've worked with CRTs, don't run them flat out on brightness. Run them just as bright enough as you need. You'll save the cathode. You'll keep the emissions high, and you won't get screen burn. I've seen these things on at work that have been on day and night in the engineering labs, and you turn them off and they still look like they're on. They've just etched into the phosphor. They burnt the phosphor away. So I'd also like to thank everyone who's supported me with this. I haven't had any negative comments, or it's just been support all the way through. It's I've really enjoyed it. I haven't let it beat me. I said all along this bloody thing wasn't going to beat me. I've spent probably twice as much money in spares as the scope's worth, but the thing is, I know that I've managed to repair it, and I'm pleased with that. I'm not worried about how much money I spent. I bought chips, I bought spare boards, most of the parts have been pretty cheap, but obviously the last big expenditure was the scrap scope that I bought, and that's fixed the problem. We're just replacing those CCDs, a couple of caps, and that's good. I also know that someone said that there is a problem with tantalum capacitors failing on these. There shouldn't be, because tantalum capacitors, in my personal experience, tantalum capacitors are great as long as you keep the ripple noise down. If the power supply's got high ripple on it, your tantalum capacitors are going to go off like fireworks. That's what happens to tantalum capacitors. If they're a good sign, actually, there's something wrong. When you start getting failing tantalum capacitors, you need to look at the ripple. They can't cope with AC ripple. They don't like AC current going through them. They're great for decoupling at very low ripple levels, but anything more than that, they go off like little fireworks. And not only that, they trash the bloody board as well, because they glow cherry red and just burn the board. Anyway, I think that's enough rambling. Thanks very much for watching. Hopefully you'll see the scope in a bit of action and a bit of use. But as I say, it's fully calibrated, and thanks for watching.